Thank you very much for the invitation to be here, and I was interested in Monica's talk about the future and kind of future projections, and a lot of the things actually she mentioned about creativity and kind of reaching out into cultures is actually what we do, but my brain's not big enough to deal with what's going to happen in 2050, although I will actually mention it during my talk. The reason why I'm just going to mention these is that I'm actually director of Barnard, and so I wasn't going to talk about this, but following on from Monica's talk, I will, because this is kind of the reality. And so Barnard is a Gates-funded project. In fact, it's the flagship of the Gates AMR-funded projects. We work in 17 sites in 6 countries. And one of the sites we work in, and I can pick on many, is actually in northern Nigeria in Kano, for those who might know it. And 50% of the babies that are born there present with sepsis, 30% mortality, and for the mothers traveling into the maternal hospital from outside, 70% of the babies are stillborn. Okay, this is their reality, I'd say. And so with Barnard, what we're trying to do is to understand the risk factors for that, and obviously try and mitigate that huge humanitarian load. I'm also honorary professor at the Chinese Agriculture University. This is the old Cardiff coat of arms, which I kind of like. Clearly, the scientists are the angels and the admin are the other people there. And so, you know, we're kind of living in this world, and you might have heard about it in the news, and in fact, David Cameron kind of kicked off really this from the British government's perspective. So for those of you who don't know, antibiotic resistance is put on the global agenda by the UK government as being right up there with global warming and international terrorism. And so it's those three branches that we're taking very seriously. So why have we gone so badly wrong? Well, first of all, is that we have the fact that bacteria are being far more compliant, if you like, and plastic and fluidity in the way in which they share DNA. And this hasn't gone on for, millions of years. This has been quite a recent event. This has really gone on for the last 30, 40 years, and in fact, the last 10, 15 years, this has actually accelerated, and so they're able to acquire a lot more DNA. Let me give you one example. There's a bug called Klebsiella, which we can sequence, and about 30%, 35% of the DNA actually doesn't belong to it. So you in the room, if 35% of your DNA didn't belong to you, you'd look like an amoeba, or maybe a modern medical student even. But so the issue is that these Klebsiella, these bugs, are able to function like bugs and are able to cause disease, but they're able to now become a little bit more pathogenic, a little bit more virulent, and of course become a lot more resistant to antibiotics. The other option, or the other point really to do with this, is the stupidity of mankind, which quite frankly has been spectacular, even by modern standards. And so we've kind of signed up to the fact that we have invested in antibiotics in a kind of a global capitalistic way. And because of that, they've been a commodity in which people can make shares and profits from this. And so trying to rein back all of that into the modern world or the modern era is actually going to be very, very difficult. So I actually work in low-middle-income countries, and I work in Thailand, Vietnam, I work in Rwanda, Ethiopia, Nigeria, and throughout South Asia. And these are many of the issues that we have to deal with. And David Cameron, I'm sure some of you remember, because it was all over the news about 1.5 years ago when he was still Prime Minister of this country, he said, we had an anti-corruption summit here in London, for those of you who remember, and he was talking about the fact that Nigeria are rocking up, and Afghanistan, he whispered to the Queen, and they're fantastically corrupt. And Her Majesty sort of just nods sagely, and it was all over the news the following day. But actually, those premiers from those countries did say, do you know what? Our countries are spectacularly corrupt. And this has massive implications into the healthcare systems, into what sort of money is spent into those hospitals and how you actually deal with patients and actually monitor antimicrobial resistance. On top of that, you have things like poor sanitation, contamination of potable water, which I'll mention later on, antibiotic stewardship programs. What do I mean by that? The way in which antibiotics are used to give to a particular patient with a particular disease, and the microbiology support is extremely weak. We often, when we think about antibiotic resistance, you might think about a relative who's been in the ward or in the hospital, and you go in and visit them, and they're not actually responding to the antibiotics because the bug that they have is actually resistant. But actually, if we kind of just take a step back and kind of scope this into what we're doing in society, is the fact that actually antibiotic resistance covers all these sectors. So we have hospital waste that actually goes down into the community. This then contaminates potable water. This then affects the community. This goes into the animal farms, and we've isolated AMR, antimicrobial resistance, from things like insects and flies and mosquitoes, etc., and you have this sort of cyclic effect that's almost impossible to arrest once it's over a certain threshold. In the UK, and in Northern Europe in particular, we kind of got these things under control. But in low middle income countries, these things are actually totally out of control. So, are we creating new antibiotics? Well, the answer to that is yes, we are. Are we creating novel antibiotics? And the answer to that is no, we are not creating novel antibiotics. Well, why is that? Well, you could argue actually that the majority of the new classes of antibiotics actually were created in the 1950s and 60s, often akin to it when sports cars were best, and now we're sort of running out of imagination or creativity, however Monica would like to describe this. So actually we have no unique classes of antibiotics that we can take into use in future medicines. The bacteria have seen it all before, and they're able to become resistant to it very, very quickly. A friend of mine, Matt Cooper in Ireland, he did a little bit of a scoping exercise. And about 20 years ago, there was between about 30 and 50,000 chemists working on new antibiotics. And now in 2017, despite this crisis, there's actually probably about 700 or 800. So we're actually not investing anywhere near the resources that we need to do to actually overcome this problem. So I'm going to give you just two examples. So we have these kind of acronyms that we use, MDR, which stands for multi-drug resistance, XDR, which stands for extensively drug resistance, and PDR, as the name would suggest, stands for pan-drug resistance. And this is an article that I wrote a few years ago now, and I discovered a new gene that gives you very high levels of resistance to a very important class of antibiotics. And we found it in India, and we called it NDM. So I named it after the capital city of India. Was it a good thing? Maybe not, in hindsight. I was accused of working for MI5. We had friends who were thrown in the Indian jail. Everybody was threatened with their livelihood. And unfortunately, David Cameron and Vince Cable had just come back from India saying what a splendid place it was and we should all invest in there. And our article came out, and within 2 days, it had 5 million internet hits, even way back in 2010. And so it was all over the news, maybe for all the wrong reasons, but actually did an immense amount of good, because it actually was one of the articles that actually put AMR on the global stage exactly where it needs to be. The other thing that we came across was this thing called medical tourism. And prior to publishing that article, I had no idea what medical tourism is. And I'll come back to it and talk about it later on in a few slides further into my talk. But we had no idea what medical tourism was. And then 3 or 4 weeks later, the whole world knew what medical tourism was and basically how insidious this particular medical trade is. So NDM is what we published. We found the gene in 2010, and this is kind of where we are now. And it's all over the world, as you can see. And the epicenter either started in Pakistan or India, and I don't really care which country it started in. The good news for me is because I was hated by India officially, the Pakistanis love me. And so we actually do an enormous amount of work in Pakistan now, and it's actually really great work in there, so that's good. And the other type of resistance I'm going to just share with you is something called MCR1. And basically, this is the article that we published at the beginning of this year, late last year, in fact. And it's a resistance that gives you, or a type of resistance that gives you resistance to the last antibiotic we use in human clinical medicine. It's called colistin. And so we've run out of everything else, and we're desperate. We actually use this particular antibiotic, colistin. And unfortunately, in China, they were using that on their farms. And so we had to talk to the Chinese government, have a very serious conversation that don't use this on your farms because you're generating resistance, and that will spread all the way around the world, and indeed it has and did. And this is where we are now. So this is just under a year where it's spread across many continents. Why has it spread that? Because people travel. Food travels and people travel. And as you sit before me in this auditorium, you have 100 at least billion bacteria as part of your human bodies. You have more bacterial cells than you do humans. They outnumber you 10 to 1. So in fact, you're actually not human, as you sit before me, okay? Just in case you're wondering. But it's spread all over the place. And the reason why I've got India there is because we actually can't get any data out of India, and we can't actually do any studies in India because it's very difficult to do this. So it was a lovely Swiss study, and they sent a load of students off to India prior to kind of going to India. So they rectal swabbed them. You can only do that with students, of course. Pay them enough money, and they went to India, had a jolly good time, and then they came back and they rectal swabbed them again. And after enrichment, about 15 to 20% of the students actually had this type of resistance. Okay, so that was in a very short period of time. Now, if you extrapolate that to the population of India, you're talking about 250 million people having this type of resistance as part of their gut flora. Then if you include China on top of that, that's basically getting on towards the population of Europe. It's massive. So the UK, as I said, have done a great job. David Cameron and Sally Davis, the Chief Medical Officer, who's done a fantastic job, commissioned this report, which is about the future of antibiotic resistance and where we're going to be as a human race in 2050. At the moment, something like about one person every 30 seconds to 1 minute dies of a common infection. This isn't HIV, TB, Ebola. This is just your standard, bulk standard bacteria like E. coli. And it's predicted that by 2050, one person every 3 seconds will die of this particular infection. It's forecast that 10 million deaths will occur every year, and it will outflank any other type of disease that we have we're facing it as a human race. So it's huge. But nobody really cares. If you say that about 10 million people are going to die, do you really care? If it's your wife or your sister or your children, you will. If it's your mother-in-law, you may not. But the fact is, when you talk about how much it's going to cost you as modern society, it's massive. And so it's predicted that it's going to cost us something like $100 trillion US. Now, I'm not an economist, but I've been told that's about 10 times the entire wealth, I don't mean the growth, the entire wealth of Europe. It will burn us as a global society, and we will not be able to recover from it. I gave a similar talk like this in Berlin 2 weeks ago, and I said, look, this is going to make Brexit look like a drop in the Pacific Ocean. It may not if the figures go a little bit higher, but at the moment it will do, okay? And it's something we won't recover from. So what are the conflicting factors of why AMR? And it's mainly anthropological. As I said before, it's about us being really stupid as human beings. So this is a website that's come from Canada. Canada is a good, sensible country, quite clean in terms of antibiotics and antibiotic resistance. But you've got an online pharmacy there, and you can buy this drug called meropenem, a really high-end antibiotic that we would use to treat very serious infections. But here you can buy it, and it's basically overnight delivery, cash on demand. And so the internet, unfortunately, has played a rather insidious role in actually pumping out antibiotics into the community. We've got no idea of how much is out there, who's taking it, no idea whatsoever. The good news is, because China has actually banned Google, is they don't have this problem, and there's maybe a secret in there for the rest of us. This is what I mentioned before about medical tourism. So this is one of the fastest growing trades in the medical industry. And figures from 2015 says that 3.2 million people travel to India alone for elective operations. And in fact, they have trackers at airports. So when you go out with your luggage, they say, do you fancy a breast reduction or a tummy tuck or whatever it may be, whatever's on the menu? Okay, so it's huge. And in fact, the number one country is actually Mexico. Number two is Thailand. So if Trump ever does build his wall, the Americans will have to go somewhere else for their elected operations. The other thing, too, is that when we think about AMR, we don't consider the sanitation issue and about the contamination of potable water in many of these countries. This is taken from Pakistan in 2012 from the flooding. It basically killed about 30,000 people, disrupted 2.5 million, and it was just a blip on our radar, covered by the BBC World Service, which is good, but it was just a blip on our radar. But actually, that actually cycles AMR throughout the entire community, and people have this as normal flora. So it's a big issue. It's a huge issue. We published this paper recently at the beginning of this year, and it was what we tried to do was to understand the complexity of what goes on in China And this just gives you an idea of a little study that we did. It was actually a huge study, but nonetheless. And we try to map in markets, farms, look at migratory birds, look at flies and dogs, etc. around the farm. And we tried to track bacteria that had certain types of resistances. And we showed the same type of bacteria that was carried by flies and by migratory birds can spread massively over farms over 100 kilometers, a distance of 100 kilometers. So therefore, when we talk about AMR, it's just not us as human beings, but once it's out in the community and once it's out in the environment, it's very, very, very difficult to track. This was some photographs that I took about 3-4 weeks ago when I was in Vietnam. And I just want to show you this, is that we have here our friend colistin. Okay, so China has actually banned this, but it's easily for sale in Vietnam. And this is the last antibiotic that we would use in the UK, in London, if you have a very serious infection and there's no other antibiotic left, but it's still being sold as a food additive to give to chickens and pigs in some parts of the world. So it's a bit of a mad world that we live in. At the moment, we have China that has banned colistin. I'm pleased to say Thailand has taken good steps, but we have other work to do in Southeast Asia, and at the moment, India is a bit of an unknown quantity. This is really important because how we actually feed the population in 2050 is very important. The population will grow by 2.5 billion people. So the chances are that we will have to become vegetarians, or we'll have to think about how we're actually going to generate the meat source for the population, the global population, by 2050. So beef and pork and lamb are likely to be rarities, and more money will go into poultry farming, rightly or wrongly, and perhaps also fish, because we get more protein per amount of energy that we put in to grow it in the first place. Finally, and this is just some data that from that same particular study that I've just showed you, and we looked at 2 types of resistances. And I just want to show you here the differences between the bar in green and the bar in purple. And the bar in green is where we've detected the DNA. In other words, the real antibiotic resistance that's out there. And the bar in purple is what we're actually able to grow in the lab. And there's a big difference between them. And so when we actually start to have a look at what we call the resistome, what we call the phantom resistome, actually in places like China and India and wherever it may be, it's actually a lot higher than what we first thought. And so that's actually really, really scary, that actually we're underplaying or undercalling, under-detecting these types of resistances. So what are we doing about it? Well, the UN met just over a year ago. 193 member states rocked up to New York to sign this document, and to pledge their allegiance to try and do something. But unfortunately, as soon as you sort of involve politics, you sort of kick the can down the road, and I'm not too sure you get good value for money. But at least something's being done about that. And again, great credit to the UK government for actually actioning this and initiating this. These are some of the things that organizations in 2017 that are trying to actually deal with this. This is XDR, this is our friend here. We have initiatives in the European Union. WHO are starting to do something. The US have CDC. In the UK, we have something called the Fleming Fund. We pumped £270 million into actually looking at surveillance in low middle-income countries. A great scheme. Projects like mine with the Gates Foundation through Barnard's, and also, of course, just the UN testimony. This is my final slide. And this guy here is a guy called Paul Ehrlich. And Ehrlich was actually the guy who first found an antibiotic. So we think of Alexander Fleming, but it's not so. He's a German guy that was around about 10 years before, actually 20 years actually before Fleming. And so he actually discovered the first antibiotic. He came up with this idea of an antibiotic, and he termed this thing called magic bullets. And I just want to read you a caption from an article that I actually wrote with a friend. Fleming's warning has fallen on ears deafened by the sounds of falling money. It seems inevitable that future generations will not only bemoan erratic patterns, weather patterns we will leave them due to global warming, but they also lament that for those who knew better, we created superbugs with little regard to long-term consequences. There is coming a time when our magic bullets are no longer magic or bullets. And I'm afraid in 2017, we're just starting to get a picture of that. And for those people in the room who are in their 50s and 60s and 70s, we're fine. But actually, for your children, it's going to be a concern. And I'm afraid for your children's children, it's going to be a fairly different type of world about how we actually treat even common infections. So thank you very much for your attention.